so we're going to do an example to calculate work, and the example states the pressure of 2 moles of argon is suddenly reduced from 2 atmospheres to 1 atmosphere's pressure. The temperature is constant at 300 Kelvin. Calculate work. So we know the formula for work is negative P delta V, and we know that pressure is going to be 1 atmospheres because we always take the last pressure in the problem, the final pressure. However, we don't know anything about the volume. So for the volume, for the delta V, which is the change in volume, we're going to need the initial and final volumes. So we can use the equation P1 V1 equals nRT. We can isolate V1. So we'll get V1 equals nRT over P1. And if we plug in numbers, we can get that V1 equals 2 moles times 0.082 liters atmosphere Kelvin per mole times the temperature, which is 300 Kelvin, all divided by P1, which is going to be 2 atmospheres, and we can cancel out the Kelvin, can cancel out the moles, we can cancel out the atmospheres, and we will be left with liters, and V1 will be equal to, let's see, 24.6 liters. And now in order to find the final volume, we can use Boyle's law, which is P1 V1 equals P2 V2. If we isolate V2, we'll get that V2 equals P1 V1 over P2. And we'll get that V2 equals 49.2 liters. 49.2 liters. So now we can plug all this information back into our original equation up here, and we'll get that work is equal to negative P, which is going to be our final pressure, negative 1 atmosphere, so our final pressure is right here, 1 atmosphere, times the change in volume, which is going to be the final volume minus the initial volume. So final volume was 49.2 liters minus initial volume, which was 24.6 liters, and we are going to get that work is equal to a negative 24.6 liters. However, we need that in joules, so we need to multiply that by the constant 101.3 joules per liter, and the liters will cancel, and we'll get that work is equal to negative 1,246 joules. Thanks, guys.